I apologize for the background noise if you can hear it. This video accompanies what I call 22A1, which is the benchmark 2 lesson on mainly slope-intercept form, standard form of linear equations, and calculating slope. So let's see what we have with this. So first section on this, they want us to find the intercepts of the graph of a linear equation. So when they talk about the intercepts, let me go ahead and sketch an example here. When we talk about the intercepts, they're talking about like the x-intercept is where the line would cross the x-axis, or the point where we cross the x-axis. The y-intercept would be the point where the line would cross the y-axis. And once we get those 2 points, we can use those and draw the line that connects those together, and we've got an equation of the line. So the intercept method is a pretty neat way to graph a line pretty quickly, especially if you have standard form. If you think about the y-intercept, the x-coordinate of the y-intercept is actually 0, and then the y-coordinate is whatever y happens to be. And if you look at the x-intercept, x is the first coordinate, which is the sideways move, but it's actually up 0, so 0 is actually in the y position. So we should be able to see that if you substitute a 0 in for y into an equation and solve for x, you have the x-intercept. And if you put a 0 in for x in an equation and solve for y, you have the y-intercept. So that's what they're showing with this example here. You've got 3x plus 4y is equal to 12. They want to find the x-intercept, so they're putting a 0 in for y, which makes this go away. Now you have 3 x's is 12, so x is going to be 12 divided by 3, which comes out to be 4. So for this line, the x-intercept is 4. That means it's going to go through the x-axis at 4. So the coordinate of that's like 4, 0. We do the same thing for the y-intercept. Now you let the x be 0, so you have 4y's is equal to 12, which means that y is going to be 12 divided by 4, which is 3. So the y-intercept is 3. So I'm going to go up 3 on the y-axis and put a point, and the coordinate of that point is 0, 3. And when I connect those together, or draw a line through those, I'll have a pretty quick equation, or pretty quick graph of the line that goes with 3x plus 4y equals 12. So to find the intercept, you put a 0 in for the x, find the y, put a 0 in for the y, you find the x. The easiest way to think about doing this, rather than doing the whole substitution thing, is just to kind of, I call it like you put your thumb over it, but let's look at number 1. Let's say if I put a 0 in for x, x actually isn't there anymore. I just have y is equal to negative 6. So this would have the y-intercept at a negative 6. I'm going to do the same thing for the x-intercept. I put my thumb, or ignore the y part, and I've got x is equal to negative 6, which means the x-intercept is also negative 6. And when I draw the line between those, I've got the graph of x plus y is equal to negative 6. So this form where you have a, x, and by, a stands for the coefficient in front of the x term. For this one, it would be a 3. by stands for the coefficient in front of the y term, which for this one would be a 4, equals c. This is kind of like the general form for what we call a standard form of a linear equation. So that's standard form. If you're given standard form and you need to do the graph, basically you cover up the x part and find out what the y has to be. Then you cover up the y part and find out what the x has to be to make it work out. And you've got your 2 intercepts, you plot them, and you draw the line. So what's going on with number 2 is this isn't actually in standard form yet. What we need to do is get this 12x on this negative 12x to the other side, and we need to get 8 to the other side of the equals also. So we can kind of pretend like there's a wall there at the equal sign, and really what we need to do is add 12x to both sides to cancel it out on the right and get it on the left. I could also look at it as like kind of jumping it to the other side across the wall, and I flip the sign. So this negative 12x moves to the other side of the equals and becomes a plus 12x. And 12x's usually come first, so we're going to write 12x out in front. I'm going to leave the minus 3y alone, and then this 8 moves across the equals to the other side, or same thing as subtracting 8 from both sides, and becomes a negative 8 on the other side of the equals. So now I have this in standard form. To find out the y-coordinate, or the y-intercept, I would cover up the x part and ignore it. So I have minus 3y's is equal to negative 8. So y is going to be negative 8 over negative 3, which is 8/3. So the y-intercept is 8/3. And I do the same thing for the x-intercept. I cover up the y part. So I have 12x's is equal to negative 8. Divide both sides by 12. I get negative 8 over 12, which, because 4 goes into 8 twice and 4 goes into 12 3 times, is the same thing as a negative 2/3. So the x-intercept is negative 2/3. 2 over 3. So this is the easiest way to find the intercepts. And also, if I was to graph these, I would, on my y-axis, I would go up 2 2/3, which is 8 over 3, and put a point. And then I would go out on my x-axis, back 2/3, so a little bit less than 1, 1/3 less than 1, negative 2/3, and put a point, and I would draw the line that would go between those. Same thing with 3. Now, one shortcut kind of to think about when you have decimals involved is to turn these into regular numbers so you don't have to deal with the decimal. So these are both tenths type decimals. So if I multiply everything by 10, I'm going to move the decimal over 1 and get rid of the decimals. So if I do that, I could actually look at this as being 45x plus 5y is equal to 90. So I multiplied everything times 10, and I avoided the decimals. Now to find the intercepts, I want the y-intercept, cover up the x term. I've got 5y's is 90, y is going to be 18. Actually, the y-intercept is 18. And to find the x-intercept, I cover up the y term. I have 45x's is 90, x is going to be 2. So this is kind of a convenient way to avoid dealing with decimals. You multiply by whatever power of 10 it takes to get rid of the decimals. If there were 2 decimal places I needed to get rid of, I'd multiply everything by 100. Okay, so let's look at one more of these. Let's look at number 6. Now, number 6, you've got your y's on one side and your x's on the other. To get it in standard form, we need to get the x's and the y's on one side of equals and the numbers on the other side. So this negative 6y needs to move to the other side of the equals. It becomes a positive 6y. And we've got negative 18x. So negative 18x plus 6y is equal to, and this 3 on the left needs to move over to the right, so as it jumps across, it becomes a negative 3. So in standard form, is negative 18x plus 6y is equal to negative 3. If I want to find the y-intercept, I ignore the x term, and I've got 6y's is equal to negative 3, so y is going to be negative 1/2 for the y-intercept. And I want the x-intercept also, so I cover up the y term, which is the same thing as putting a 0 in for the y. I've got negative 18x's is negative 3, and negative 3 over negative 18 is the same thing as a positive 1 over 6. So this line is going to go through the y-axis at negative 1/2, and it's going to go through the x-axis at 1/6, and we could plot those points and then sketch the graph, or sketch the line that goes through those 2 points. So it's super easy to do a graph from intercept method, or from the standard form. What you might have to do, though, is move things around a little bit to get it in standard form to begin with. Okay, and this is going to be super important as you get into Algebra 2 and into higher math classes. So let's look at slopes now. So this really should be a review. Remember, the slope formula is slope is equal to y2 minus y1. over x2 minus x1. I like to look at it as change in y over change in x. So I use delta or triangle for the change. And another way to look at it is rise over run. So we have three different ways of thinking about slope that are really kind of all the same way. So we want to find the slope of the line. Let's do A and D. Well, A, C, and D. So we want to find the slope of the line that passes through 1, 5, and 4, 6. The difference of the y's, 6 take away 5, would be y. I'm going to let this be my 2 point, and this be my 1 point. So 4 is my x sub 2, 6 is my y sub 2, 1 is my x sub 1, and 5 is my y sub 1. So I'm going to do y2 minus y1, 6 take away 5, over x2, which is 4, minus x1, which is 1. And usually I just plug the numbers in. It's almost like you have a block minus another block over a block minus another block. And all you have to do is just insert those numbers in the first step. And then for the second step, I think about actually, how the numbers are going to work out. So 6 take away 5 gives me a 1, and 4 take away 1 gives me a 3. So the slope of the line that goes through 1, 5, and 4, 6 is 1/3. This line is going to go up 1 and over 3 as it goes from 1, 5 to 4, 6. And every point on the line is basically going to be over 1 and up 3 from another point on the line. Okay, let's look at C. Now, notice C, before we get started, notice that the y numbers are the same in C. So let's see what's going to happen with that. I'm going to do y2 minus y1 again. So 7 take away 7. Again, this is my 2 point, this is my 1 point. I've got 7 take away 7 in the numerator, and 8 take away negative 2 in the denominator. Now, this take away negative business is one reason I just kind of just go ahead and fill the numbers in with minuses in between. And then for the second step, I worry about how things are going to work out rather than trying to do them in my head. So 7 take away 7 gives me a 0. So we have a 0 in the numerator. And 8 take away negative 2 is really, if we think about, these two negatives being next to each other is canceling out. Or I like to look at this as plus opposite. Always turn a subtraction into a plus opposite what the next number is. So this actually turns into 8 plus 2, which is 10. So this is going to be 0 over 10, which simplifies to 0. Now, a line with a slope of 0 is a horizontal line. It actually has 0 rise over the run. So if we kind of think about what that means in geometry, if we're starting out, say, a point here, as x gets bigger or as x gets smaller, there's no rise, there's no change in the y. So it stays level, which makes it a horizontal line. So as kind of like a special case, a line with a slope of 0 only has the y number that matters. The equation of this line would actually be y equals 7, because the y's are always going to be 7. It doesn't matter what the x is. Now let's look at D. These sort of is a different case here. Notice with D, the x's are the same. So let's see what happens with that. We're going to do 2 take away negative 8 for the change in y's over 6 take away 6. So 2 take away negative 8, if I do plus opposite, is going to be 2 plus 8, which is 10. And the 6 take away 6 gives me 0. Now we can't have division by 0. That's actually undefined. So actually there is no slope that we can find for the line that goes between 6, negative 8 and 6, 2. Now if we kind of look at the points here, the x's are the same and the y's are different. If we kind of plot those, we've got 6 over 6 down 8, and we've got over 6 up 2. We can kind of see that these are all going to line up in a perpendicular line or vertical line. So you should remember this special case. If you have no slope, not the same thing as zero slope. Zero slope is not no slope. Zero slope just means you have a horizontal line. You've got a level line that doesn't rise. But if you actually have no slope, because you can't calculate a slope at all, that's always going to be a vertical line. This is the one case where you can't write a y equals equation to represent this line. Only the x's matter, and the x's are always going to be 6. So this is the line x equals 6. It would go through 6, -8, and 6, 2. So if you recognize this kind of as a shortcut, that the x's are the same, then you've got an x equals whatever that x number is. If you recognize that the y's are the same, you have a horizontal line where y is equal to whatever the y number is in the coordinate pair. Okay, let's move on to the next side of the page. So what they're doing with A, B, C, and D here is they're actually going through and they're working these out, showing the substitution into the slope formula. Let's look at, here we have some practice ones. You were supposed to do the odd ones for practice. So let's take a look at these. Remember, I'll go through these kind of quickly. 6 take away -9 over -9 take away 6. So 6 take away -9 is the same thing as 6 plus 9. Again, plus opposite. You get 15 in the numerator. And -9 take away 6. Now, if we do plus opposite with this, we've got a -9 plus a -6. The rule for adding sign numbers is if the signs are the same, you keep the sign, you add the numbers. This is going to give me a -15. So that simplifies to a -1 for the slope. So 7 has a slope of -1. Let's look at number 9. We would do 5 take away 8 over 13 take away -11. Again, this take away minus cancels out, turns into pluses. 5 take away 8, do plus opposite with that. We have 5 plus a -8. Two different signs. You take the sign of the largest magnitude number, which is the negative. So the answer is going to be negative, and you look at the difference of the numbers, and the difference of 8 and 5 is 3. So this is going to give me -3. And 13 plus 11 gives me 24. So -3 over 24 is the same as a -1 over 8. So the slope of that line is -1/8 for number 9. Let's look at number 11. We've got -9 take away -5 over 5.5 take away 2.5. Now this take away -5 cancels the negatives, and it's the same thing as a +5. A -9 plus 5, biggest number is a negative, and the difference of these is 4. So we get -4 out of those. And 5.5 take away 2.5 is 3. So we get -4/3 for the slope that goes with number 11. So those are our slopes that go with 7, 9, and 11. And then the bottom gets into graphing using really, like what they are doing here is they're turning this standard equation, standard form, into y equals mx plus b. Let's look at what they did there. To get into y equals mx plus b, basically you need to kind of lock the y where it's at on the left side. And so when you look at it, you've got this negative x you need to get rid of, or needs to be accounted for on the other side. And also this 2 needs to be gotten rid of. And the best way to simplify is to, I call it like you work PEMDAS backwards. You want to undo any added subtracted parts before you undo any multiplied divided parts. So I want to undo this minus x by moving it to the other side where it becomes a positive x. So we have x plus 4 on the right, and we've still got 2y on the left. Now I need to get rid of this 2 that's times the y, so I divide everything by 2. I get y, and there's a 1 coefficient out there in front of the x, even though we don't write it. So 1 over 2 gives us 1/2 x. So the slope is going to be 1/2 x, and then 4 divided by 2 is going to be 2. So the slope-intercept form of this equation is y equals 1/2 x plus 2. So they're starting with the y-intercept, which is 2, plotting it on the y-axis. Then they're applying the slope, which is rise over run, or change in y over change in x. And they're going up 1 and over 2, making another point, and then they're drawing the line. Now I want to point out that if you have standard form, you have a super fast way of doing the graph. So let's look at this way. So we have minus x plus 2y is equal to 4. I'm going to go for the y-intercept by ignoring the x. I've got 2y's is equal to 4, so the y-intercept is 2. And then I'm going to ignore the y part. I've got negative x is equal to 4, so x is going to be a negative 4 for the x-intercept. And I can plot these 2 points on the graph and draw the same line. So the x-intercept is a negative 4. It's going to be this point back here. And the y-intercept is 2. It's going to be this point here. And then I've got an easy way to draw the same line. So it's super easy to graph, like 15 seconds or less. You can do a graph from standard form. Or the traditional way is to graph from slope-intercept form. But if you're lucky enough to be given standard form and you need to do a graph, the easiest way is to use what we call the intercept method, which is ignoring the x, putting a 0 in for the x and seeing what y is, and then you ignore the y, or put a 0 in for the y and see what the x is.